All right, so today we're going to talk about congruent figures. And we kind of talked a little bit about it yesterday, but we haven't really gotten into like a lot of the details as far as congruent figures. Yesterday we kept it pretty surface and we just said, we know that when shapes look the same, that means that they're congruent. But there's more that we can do with shapes that when we know that they're congruent. There's something called a congruent statement. And when we have a congruent statement, we can do a couple of things with it. So we're going to kind of go over that today. And we're going to do some more practice on being able to identify what transformations maybe happened to get one shape to look like another shape. So kind of what we were doing yesterday with that worksheet. The very bottom of our notes here has some additional examples of that. So if you're still feeling a little like about what we did yesterday, maybe by the end of class, after a couple more examples, you'll start to feel a little bit more confident with that. Remember, though, in the past, we've talked about something called rigid motions, and rigid motions would be those isometric transformations. And so remember, isometric meant that it kept or it preserved the shape and the size of whatever it is that you're working with. So it doesn't make it any bigger, doesn't make it smaller, doesn't add sides, take sides away. And we've already been working with this in this unit. When you guys were doing your reflections, your rotations, translations, and that, you've already been working with congruent shapes. We just maybe haven't talked about it yet. Figures are congruent if they are the same shape and same size. They might also say something like shapes that carry onto each other. Again, we've kind of talked about those, like when we were working with our functions and we talked about like mappings versus transformations. It's kind of taking some of those ideas here, but it's just kind of pinpointing on like very specific cases here where everything about the two shapes looks exactly the same. And the rigid motions that we've already mentioned today that we've been working with are reflections, rotations, and translations. And in that picture on the top corner of your page, it's kind of showing you a little bit of those things. Like there's a translation happening from BCD to B prime, C prime, D prime. And then it looks like they also did a reflection. And that's how we got to that BCD double prime shape. But we've already been working with this a little bit. You've been combining those transformations together. And we practiced a little bit more with that yesterday of just being able to identify them. And we're going to do more of that later today as well. Now that we know kind of what we're talking about here with congruence, I want to talk about something that's called a congruence statement. So this could be given to you with or without a picture of the shapes that they're talking about. Sometimes they'll have like a graph and they'll put the shapes on there that they're talking about. Other times they won't. Sometimes they'll just give you the statement and then they want you to be able to pull some information from it. When you have a congruent statement, there's things called corresponding parts. And basically what that means is when you look at the names of your shapes, if they're in the same position, they should be able to connect and like mean something to each other. So when I look at this statement here, it says quad, A, B, C, D. Quad's just short for quadrilateral. So they're talking about some shape that has four sides, A, B, C, D, and they're saying that's congruent to another quadrilateral, M, N, O, P. Now on my screen up here, you guys can kind of see it's color coded, right? Yours isn't like that, okay? All of your stuff is going to be in black and white. So whether it's color-coded or not, we should be able to think through how would I know how to pair up things? What do you guys think? How would you know how to pair pieces up? Jackson?
Like whichever two are next to each other, I guess.
Okay.
Like A, B, B, C, C, D, and then like M, N, N, O, and then P, O, P. But then you can also go with like P, M if it's like you can like go with a first and last line.
Okay.
Because they would be connected.
Yeah, okay, I like that. Keegan?
The order the letters are on the paper.
The order of the letters on the paper. Yeah, that's kind of going along with what he was saying. Like he was kind of pairing up two letters together, but we could actually individually pair up the letters too, right? And so you might even see that up here on mine, because it is color coded, that certain letters have certain colors because they're trying to tell you, like, hey, these letters would have to match each other on your shape. So I don't have a picture of these quadrilaterals, but if I did, the coloring, like color-coded letters, are telling you like they should look the same in your figure. And so what I want to be able to do is list out what are my congruent angles and what are my congruent sides. I don't need a picture to do that. All I need is my statement in order to help me do that. I'm going to start with the angles. And kind of like using the combination of what you guys had told me, I'm going to use the order of the letters to help me do this. So A is first. So I'm going to say angle A is congruent to the first letter over on this shape is M. So I'm going to say angle A is congruent to angle M. Again, I can see that a couple of different ways. They're both first in my names. They're also both colored the same color up there. They're both black. So that just also tells me like those are going to go together. Now, B is the second letter. It's also red. So that should match up with the second letter over here, which is also red right now. So B and N should go together. So I'm going to say angle B is congruent to angle N. What are the other pairings of angles that we could add on? C and O. Good. And then angle D and angle P. Make sure you're using the correct symbol there. We want that angle symbol in front of all those letters. We want the congruent sign in between because we're saying these two angles from the two different shapes should match and look the same if I had a picture. Now I can do the same thing with sides, but when I name sides, we're not going to use an angle notation anymore. And I'm not talking about lines here. I'm talking about line segments because I'm talking about like specific pieces that make up these shapes, and they're not going to go on forever and ever and ever. Do you have an idea?
You put the line segment symbol above instead of the letter.
Yeah, instead of the angle, we're going to use that line segment symbol. And instead of one letter, I need two now. Because if we're talking about a segment, it's got to have a start and an end. So AB would be one of them. And that could match up with M and N. Because A and B are the first two letters, M and N are the first two letters, so they need to go together. What about BC? What does that match up with? Good. NO. What would be the next side you could write down?
CD and OP.
Good. CD is congruent to OP. And there's one more side. What is it? Greer? So DA is congruent to PM. Could I have flipped that around? Could I have said AD and PM instead? Yeah. Okay, here's another. So I'm going to write here. Or you could have said AD is congruent to MP. Okay, here's a follow-up question. On this first one, do you guys think it would be okay if someone said this?
No,
Why not?
because you split one of them and not the other way.
Yeah,
You split one, you have to split both.
you have to be consistent when you guys are naming these things. But let me tell you, I see this mistake happen. Someone does this every year where they don't pay attention to what they're writing down and they just start willy-nilly throwing all these letters around. Okay? This is no good. I don't want to see stuff like that. You have to be intentional about keeping matching letters together. So if you're going to flop the order around, that's fine, but be consistent and do it on both names. Make sure you flip both of the letters around. You can't just do it to one side, because then what you're doing there on that one is you're trying to say that A and N should go together on the shapes, and that's not true according to our statement up there. Okay, so just be really careful when you're writing those things down. Make sure you're putting the right letters together. And then like we have been seeing with all of those, we have that congruent sign, and we talked about that today in our bell ringer, but remember that just means same shape, same size. All right, here's what I would like you guys to do down on this next example here. They're giving you, for part A, a set of triangles that are congruent, and then for part B, they're giving you quadrilaterals. What I want you guys to do for part A is just to list the angles. And for part B, why don't you list the sides? So instead of doing both for all of them, go ahead and just do angles for part A and do sides for part B. Go ahead and take like 2 minutes to do that on your own. Once you've got them written down, why don't you compare with a neighbor and see if you guys agree? All right, someone want to tell me what they wrote down for part A? The angles, Greer?
Angle A is congruent to angle H. Angle J is congruent to angle J. And angle R is congruent to angle M.
Good. Okay, over here, someone else want to tell me the sides? Keegan.
Line segment HJ was congruent to line segment WS.
Okay.
Line segment JK was congruent to line segment SR.
Good.
Line segment KM was congruent to line segment RT.
Good.
Line segment MH was congruent to line segment TM or TW.
Looks good to me. Awesome. We understand how to do that, guys? Okay. Now, yesterday when we did that side flip turn worksheet, we were doing a lot of this where we were trying to move shapes around to get them to be laying on top of each other and like writing out in the notation what was happening. We're going to practice a couple more here with that. Again, if you need to, patty paper is a great resource to use right now, especially if you want to actually do the reflection or rotation before you commit, so you can kind of see if it's going in the direction that you want it to go. So don't be afraid to pull that out. If you still have a piece of patty paper from yesterday and you need it, use it, okay? Because on like your test, you're going to be allowed to have patty paper. So use it as a tool, just like you would use a calculator to make sure that you're solving things correctly. Or just like we used compasses in the first unit to make sure we were doing things correctly, we want to make sure that we use that patty paper if we need it. So let's start on this first one. The only difference between what we did yesterday and what we're doing now is they're adding on that they want you to be able to fill in the rest of that congruent statement. So they've got it started for you there. It says triangle ABC, and they're trying to just have you fill in the second half. What would it be congruent to? What triangle? Now, some of you might already know how this is going, like what's going to happen with our first shape to get it to look like the second one. So some of you might already be able to see, like, I know it's going to be these 3 letters. And that's great if you can. But I also am going to need to see what did you do to the shapes to get them to map onto each other. If you kind of get stuck on, I don't know where to start, or I don't know how to begin these, think about how do I get my shapes to be facing the same direction first. So I'm going to start with triangle ABC only because that's the first triangle in my congruent statement. So that's the one in blue. I want to get it facing the same direction as the other one in orange. How could I do that?
Reflected across the y-axis.
Okay, so let's reflect across the y-axis. Now let's start. How do we write that down notation-wise?
Little r y-axis.
Good. Little r y-axis. And then after that, I'm going to put triangle ABC because that's what I'm doing this to. I need to see that in your parentheses. So in the future, if I gave you this, but I didn't give you the congruent statement, I just had like blanks for both of them, you could decide then what shape you wanted to start with, but you have to tell me that somehow. You have to put the shape that you started with in that parenthesis notation so I know, okay, they started here, and this is what they did to it to get to that next shape. You got to be specific and clear on that. I can't be sitting there guessing and checking things. All right, so let's do that. My y-axis is that line that goes up and down. There's a couple of ways you guys could do this. You could use your padded paper to do your reflection. You could count how far the shape is from the y-axis and then just go the opposite direction. Or you have rules for the y-axis reflection. So if you knew the coordinates, which you could find them, you could then apply the y-axis rule to them to get your new one. So you have some options here as far as how you want to reflect it. What I'm going to do is just count squares up here. So I'm seeing that A is, I know it's kind of blurry there, but it looks like it's about 6 to the left of the y-axis. So I'm going to go 6 to the right. I'm going to call that A prime. C looks like it's about the same. It's 6 to the left here. I'm going to go 6 to the right, and I'm just up 1 square. So there's my C prime. How far from the y-axis is B? 3. So I'm going to go right here, 3 to the right. That's my B prime. And there's my ABC prime triangle. Okay. What do I need to do now to get this one to line up with that one underneath it? Translation. And what directions are we going here? Down. Now, when you're counting, you just need to focus on one set of points that you want to have line up. So like B prime should be landing on what letter? E. So I would just count the spaces from B prime to E. So 1, 2, 3, 4, 5, 6. We're just going down 6. And that would be negative when we're thinking about going down. How would I write that down here notation-wise?
And it's 0.
Good. 0, -6. And then I'm still going to put triangle ABC here. Okay, so now let's fill in that statement at the bottom. So if I imagine taking that whole triangle and I just shift it down, ABC should be congruent to what triangle?
DEF.
Say that again.
DEF.
DEF. Very good. Okay, let's do the next one together yet. Are they facing the same direction right now?
No.
How do you tell? Is there something that you're looking for to decide if they're facing the same way or not?
See if you can find it different.
Yeah, can you just like slide that over and line it up? I mean, the BC and the SP look okay because those are both the same. But when I'm looking at that top shape, that A to B segment looks a lot longer than even R to S does. So I think what I want to do is flip this somehow so that I can get them to be facing the same direction. Anyone have a thought on how to begin?
Reflect over the x-axis.
Okay, so again, little r for reflect, x-axis you said. And we're starting with this quadrilateral ABCD. And again, I'm just grabbing that from my statement down below. So I'm going to write quad ABCD here. Again, if they didn't have anything written down in that congruent statement, then you could decide what shape you wanted to start with. And you could go the other way if you wanted to. All right, so let's go ahead and reflect that. I'm going to count my squares. So for D prime, I'm going to go down 1 from the x-axis. A prime, I'm going to go down 7. C prime is down 3. and B prime is down 5. Are they facing the same direction now? Yeah. Okay. What do you want to do next? Greer?
Translate down to and then to the right.
11. So how would I write that as a vector? Does the 11 or the negative 2 go first?
2, because it's the X.
Well, we went right 11 and we went down 2.
Oh, 11.
So 11 has to go first because that's your X movement. So write 11 and then negative 2. And we're still doing that to quad A, B, C, D. Again, all we did there is we counted squares. So like A prime needs to land on M. So I went over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then down 1, 2. That's where we got those numbers from. How would you guys fill in your your congruent statement here?
DCBA.
We started with A, B, C, D. So I want letters from the green shape. How would they go?
MPSR.
Good. M, P, S, R. Okay, why don't you guys try that third one on your own? See what you can do with it.
Wait, is it 6 away? I'm looking counting wrong.
Yes. Are you doing it from the x-axis?
Yeah.
Yeah, it's 6 up. So
Okay.
you'd want to go 6 down. Okay, I'm going to go over this. I'm going to show you what I would do. And it's okay if you have something different. We talked about that yesterday too. The nice thing about these problems is that there's a lot of variety as far as answers go. So just because I write something down doesn't mean that what you did is wrong. If you found a different way to go about it, great. All right, what I did first is I wanted them to be facing the same direction. So I took that quadrilateral QRST and I did a reflection over the y-axis. Okay, so from my y-axis, I counted how far apart my points were. So T is over 7. So there's my T prime. S was over 3. Q is over 5. And R is over 5 as well. It's just up a little bit higher. Okay, then what I did is I did a translation. I need to get like T to pair up with J. And to do that, I had to go left 1, and then I had to go down 1, 2, 3, 4, 5, 6 squares. So to write that as a vector, I went left 1, so that's negative 1, and then I went down 6, so that'd be negative 6. And then I still did that to quadrilateral QRST. Now, if you had different movements than me, like I said, that's fine as long as you get it straight there. Some of you might have reflected over the x-axis instead, and then maybe you did another reflection in order to get it. Or maybe some of you even wanted to do like a rotation with your shape. But no matter how you get those shapes to match up, we should be able to fill out our congruent statements the same way. What letter should go in my blank here?
PLKJ.
Everyone agree? PLKJ there? Okay, good. Any questions on what we talked about today?
Guys, bathroom.